Okay, the last four, quiet, on your assignment were actually proofs, but remember we just went through and just said what reason makes them congruent. So again, eventually you're going to have to do these proofs on your own. So I'm going to go through these for you. So when you're doing a proof, you're always going to be given something, and you're asked to prove something. So what's given to us here is that two lines are parallel.
Why doesn't that jersey say Vikings? Just because?
Why doesn't it?
Yeah.
This is the jersey they wore in the early 80s.
Hey, it's signed. That's you just noticed.
Okay, so they gave us two givens. Now remember, in your proof, you got to have three things. Side, 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 angle, 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 side. So in this one, they gave us one thing. We know, this one is congruent. We know a side right there. So you got to put two more things in there, whether it's another side or another angle or two more sides or two more angles. So looking at this picture, there's two ways I could solve this. Before I go ahead and write in here, if you look at vertical angles are congruent, right?
Yeah.
And since these lines are parallel, that means alternate interior are congruent. So this would equal that, and this one would equal this one. That's why when we corrected these, I said you could have two possible answers. You could have ASA, ASA, or you could go angle, angle, side. Or this way, angle, angle, side. So this is one that has two reasons. Sometimes you're going to have a triangle where there's one more reason. There's actually five we can use, where all five of them would work. So you don't have to put all the information in there. What I would do is, vertical angles are always easy to spot, so I'd put that in there. Angle FGH is congruent to angle KGL. Because vertical angles are congruent. So there I got another angle. Then I got a choice. I could either say these two are because they're alternate interior, or these two. It really doesn't matter which one. Since I already have these marked, I'll do these two. Angle HFG is congruent to angle GLK because those are alternate interior angles. And there I've got my third thing. There is one more thing I could put in there, and it wouldn't be wrong if you did, but you just don't need to. So then you put your proof statement last. And from what I did, what I've got marked on there, which reason is it that I use to say they're congruent?
The third.
Parallel lines.
Yeah.
No. No, remember, is it ASA, SAS?
Oh.
From the way I did it, which one did
Angle, side, angle.
Angle, side, angle. ASA, ASA. So remember, your final proved answer is going to be one of those things.
So it's produced just like yesterday.
Yeah. Well, this is yesterday's, it's just we're actually doing the proofs. The next one.
Oh, you're going to make us do the column?
Yeah, pretty soon, in like a couple more lessons, you're going to have to start doing them on your own. So here they're giving us a bunch of stuff. AB perpendicular to AD, DE perpendicular to AD, BC is congruent to EC. Now, you could write given each time, or you could just go like that and say that they're all given, which I'm guessing most everyone would do. So what I know right now is I only know one side. But it's marked here, but it's not in my proof. Since these lines are perpendicular, that means these are equal, right? And the way you can write that a number of different ways. You could say angle A is congruent to angle D, and they both equal 90. Or you could say A and D are both right angles, or A equals, well, I guess this would be the easiest way to do it. Now, the reason why I can say that, and again, a lot of this is sometimes just common sense. Why can I say that they're equal to each other and they equal 90?
They're perpendicular.
Definition of perpendicular. That's why they gave us this, so you could write that. So there I have a set of angles. So I need one more thing. What's true in the picture without you having to be told anything? Huh?
Vertical angles.
Vertical angles. So angle ACB is congruent to angle ECD.
Would you have to write it the other way?
Huh?
Can you start with A? Would you have to write the same the other time?
No, you could call this DCE or ECD, it doesn't matter. Vertical angles are congruent, so there I've got my third thing. So then you can put your prove statement in. And what's the reason?
Angle side.
Angle, angle, side.
Angle, angle, side, or side, angle, angle. Angle, angle, side, or you can go backwards, side, angle, angle. Okay, number 21, they give us almost everything. So they give us 3 givens, and 2 of them are sides. So we only need to find one more thing. So, since these 2 are parallel, that's given to us right there. Whenever you see parallel lines, some angles are going to be equal. Usually on these, it's going to be alternate interior. In this case, they're corresponding, because this is the parallel line, and this is the parallel line, and this would be called the transversal. So these are corresponding. Everyone see that? So I can put that in my proof that angle VXW is congruent. I can just put Y because it's the only angle there. And the reason why they're congruent is because corresponding angles are congruent. So there's my 4th thing. So then once you have, or I mean my 3rd thing, then you can put in your proof statement. Triangle VXW congruent to XYZ. And what's the reason for that one? Side angle side, side angle side. SAS.
Why didn't you put just Y?
Since there's only one angle right here, I could just use Y. I could call it VYZ.
Oh, you can.
Yep. But it's just shorter. I can't just call this X because then it could be any one of these 3.
Oh, yeah.
But when there's just one, you can just use one letter. And then the last one, it's kind of confusing the way they got them overlapping each other. So they give us that 2 angles. So we know 2 things. we know an angle, we know another angle. So it's maybe a little hard to see on this one. If you could split these up, it'd be a little, I'm gonna make them a little smaller, but this would be triangle RQS. And then this would be TSQ. They tell us that these two are equal, and they tell us that this angle here equals that angle there. So what else is true on those?
Angle on the side.
That's what it's gonna be, but we don't have the side in there yet, so you gotta put that in your proof. Everyone see which side it is?
So can we say angle or S is congruent to Q?
SQ, side SQ is congruent to side SQ because it's a shared side. So SQ, well, you don't need the line for that, if you can put it though. And the real reason, if you forget, you can put shared side, but the real reason is it's reflexive. Anytime it's shared, it's a reflection. So there we've got the side.
How many of those do we need?
All you need, this is all we would need here because we have the three things. We have enough. So then you put in your proof, triangle TQS. Because what was it, angle side? Okay. So, today, I'm going to show you the fifth. Yesterday's assignment was saying why triangles were congruent, and you had 4 to choose from. There's actually 5. Angle side. And remember, angle side could be written backwards. The fifth reason only works on right triangles. So, just a hint for you. Anytime you see a right triangle, try this one first. Doesn't mean it'll always work, but that's the one you should look for right away. And it is called HL. On a right triangle, can you guess what the H stands for?
Corner. No.
What are the parts of a right triangle?
Oh.
Hypotenuse.
Hypotenuse
And a leg.
and a leg.
It sounded better.
Hypotenuse, leg. So if you know the hypotenuses are equal and you know a leg is equal, then they will be congruent. Now, the reason why they call it HL, I'll show you what it would look like. I'll use this picture again. If we got two right triangles, and I know that the hypotenuses are equal, and the leg is equal, this would be HL. Now, if they didn't use HL, what would this spell out?
Wouldn't it?
Huh?
Yes.
Oh.
It'd be what?
ASS.
ASS.
Oh.
So that's why they use HL. Now, angle side only works if it's a right triangle. If it's not a right triangle, ASS won't work. So that's why they don't have ASS, for another reason why, other than being a bad word.
Hypotenuse leg.
Yep. So if it's right triangles, then you just check the hypotenuse and leg, and this would be HL. Now, it's not always going to be hypotenuse leg.
Is it pretty much only when it's a right triangle? that
It
you
is.
do that?
The only way you can use HL is if it's a right triangle. It has to be right in order for it to use HL. So, it's not always, because if it were written like this now, this one is not HL because you don't know the hypotenuses. But, what would you call this one? SAS. So, again, just because it's right doesn't mean it's gonna be HL, but a lot of the times it will be.
Wait, so if it doesn't have what? It's HL?
If it's HL, it's gotta be right, and you need to know the hypotenuses and a leg. Yeah,
So if it's right and you know the really long line,
yep.
So why aren't those HLs?
This one that I just had here,
Because of the.
because I don't know the hypotenuses.
Oh, the hypotenuse is the.
Hypotenuse is the longest side, the one opposite the 90. But I do know side angle side on both of them.
Okay.
So yeah, on the if it's HL, it's got to be right, and you do need to know the hypotenuses.
So now it's
Now it's HL. Huh?
HL. Hey, look at this, look at this.
Shh. What? Yeah, you do. So I know this leg and that leg. So you need to know one leg and the hypotenuse. And that it's 90, obviously. Okay? So on Monday, you're going to have a worksheet.
You don't have any homework today?
No homework today. Monday, it'll be a worksheet where it's just like the last two assignments. You got to say what would make them congruent, but it now includes HL.
Oh, so it's just the same thing.
I'm not going to be here.
Who's gonna be here for you?
Mrs. Graff.
Oh, I thought you were gonna say Miss Gray.
Oh, my God. You should have Mr.
But remember now, some of those on the worksheet can be no.
Harry, you don't have Wi-Fi.
So don't forget that.